Hi, good morning everyone. This is the Google Hangout for the Carrier Ethernet group that I had promised you all in a couple of emails last week. So welcome to everyone from a sunny California. And as I mentioned, I have Scott Rainovich of the Raino Report with me. He's going to be our special guest and educate us on what he has been doing in the area of cloud WAN. So good morning, Scott. Warm welcome to you.
Good morning, Michelle. How are you?
I'm very well, Scott. I'm very well. I'm sure that the listeners and anybody else who's going to be looking at this video later on are looking forward to hearing what you've been looking at in the cloud space. So, folks, a few points of logistics. First of all, how to ask questions. So basically, Scott and I thought that the best way to ask questions would be for us to do that on the LinkedIn page. And I'm going to show you that in a moment. But first, let me tell you, this is the first time we're doing this. So guys, if something goes wrong, please come back in a few minutes because, glitches can happen and Murphy's Law usually happens when you're not expecting it to. So, if we go off air or something happens, Scott and I will sync up and we'll restart the laptop or the computer and you guys just have to come back in a few minutes. We'll get better at this with time. The other is the question. So let me quickly do a screen share here, guys, and show you where we can actually ask questions. So I think the thread that we have for this on LinkedIn, which is right here, is the best place for everyone to ask questions. So this is, if you go to the LinkedIn group and you go to the discussions tab, and right at the top there are the manager's choice discussions. As you scroll through it, this is discussion number 2 that will come up. You'll see the title. And when you scroll down to the bottom of it, this is where it would be easiest to add your questions, because this is one place we can consolidate everything and look at what you're talking about. And periodically, as we go through this, I expect this to last about 50 minutes or so. I'll check for questions here, and if you've put something there, we can address them. So that's about the questions. Now let me talk a little bit about why are we actually, okay, sorry, I didn't select present to everyone. So let me just quickly recap that. So guys, as I mentioned, this is the screen on LinkedIn where the initial discussion post was done. And to consolidate all questions and keep everything in one place, we're going to use this as the hub for all of our questions. So as we go along, as I said, I'll keep asking for questions. It'll be great if you can type them there. If by chance you're unable to do that, then please email your questions to ceLive@metanoia-inc.com in case you don't have access to this web page. And I'll be checking my email here on my smartphone, and I can answer questions that way. So we should be covered on the questions, and we'll periodically keep a call out for the questions. So let me then move on to a little bit about why are we doing this and where did it all begin. So the Carrier Ethernet group has grown tremendously in the last 1.5 to 2 years. In fact, I think it's very instructive to look quickly at some of the statistics. So I'm going to actually share a different screen and show you guys how interesting the statistics have been in just the last 2 years. So here goes. So as you can see, we've been growing almost 50% for the last 2 years, not only in the discussions and the quality of the discussions also, but in the comments, which is an indication of the participation of the people in the group, the increased involvement of the members and the value that they're getting from the group. And of course, the membership, as you can see, has also been growing. In fact, just at the end of this month, we are at 8,450 members, which means we added about 150 people in just the last 30 days alone. And in terms of the discussion, also in January of 2015, we pretty much exceeded the discussions that we've had just last year by about a 30% margin as well. And the quality of the discussions has been going up steadily. So as a result of that, about 6 or 7 months back, I just out of the necessity of trying to make sense of this all, I began to summarize in a weekly update the most interesting discussion that were happening in the group. And so that process began in June sometime, and then I continued that and on and off as time permitted, and gradually over the last maybe few weeks, this evolved not only to a weekly update published on LinkedIn, but a weekly update actually. I'm sorry. So here's the growth of the group. I'm sorry I didn't share that with everyone. That's a bit of a learning exercise here. But as you can see, the group has been growing in every dimension by about a 30% margin. And that, as I said earlier, is a reflection of the increased involvement of the members and the value that folks are deriving from participation in the group, which I'm very happy about. It's great involvement from some very senior people in the industry, from new people who are from around the world asking questions about implementations and strategy and technical questions, some of which we'll get into in a little bit of depth a little bit later in the broadcast. And you know, it's a reflection of the involvement of the group. So as a way of making sense of this all, a few months back, I began to publish the weekly updates. And what I did as a result of that is try to start putting them initially on LinkedIn. But soon the quantity of information got well beyond the limits of LinkedIn, and I began to publish the details on my blog. So let me quickly share that with people so you know where you can find information that summarizes the activities of the group. And that is actually found on the blog post. Just a moment here. Okay, just a sec. Oh, I realize it doesn't let me share the screen until I have it open in a completely new window. So there we are. So let me share the screen and make sure I present to everyone so all people observing can see it. So this is the blog post archive, if you will, on the Metanoia Inc. website, and every one of the weekly updates published on the group has a pointer to this. And as you can see, we've had quite a few blog posts over the last maybe 6 to 9 months. There's about 15 or 20 blog posts capturing things every week or a couple of weeks. The latest was published on the 10th of January. And then as a way of evolving this whole discussion, I decided that it's probably time to actually do a hangout, because that would be a way for us to interact in real time, for me to bring in guests like Scott here, and maybe others, as you know, some who are contributing to the group, who are actually making observations, and are therefore the best positioned experts to explain certain aspects of technology discussions that they've presented on the group in terms of their posts. So this really has been the evolution of this, and the purpose behind this is actually, in effect, it was a learning exercise. You know, as I said, I was trying to make sense of some of the remarkably useful discussions that were happening on the group, and this was a way of consolidating and making sense of it. But it's also a way of giving back to the community and sharing with everyone, because I know that sometimes there are 30-40 discussions in a week. It's really tough to kind of follow things, to know what are the things that we really want to focus on, and even to see what different categories they belong to. So as a result, I began to kind of organize things by category, focus on the most important and valuable discussions, and these blog posts and the summaries that you're seeing is a reflection of that. And then the next logical step, I thought, was to have a broadcast like this and start talking about what we are doing in the group, which actually is a positive feedback cycle, because a lot of the discussions that are not possible perhaps in a discussion format could be done here on a live hangout. A lot of questions could be answered, new questions could be raised, and so forth. And some of the things that are very difficult to answer real time, or maybe even we may not even know the answers up front, we can take back to the group, we can think offline and come back and have them answered on the group. And the objective of the group, as you all know, is to collectively improve our learning, improve our understanding of the industry, not just from the bits and bytes perspective, but also from where is technology going? You know, what's really happening in the industry? As many of you have seen from many posts that Scott has done, that Tom Knoll has done, and several other members have posted, the industry is changing, you know, and it's changing rapidly. The cloud, SDN, NFV, big data, analytics, evolution to network as a service, the combining of the cloud with the WAN, and so on and so forth, the combining of the optical network with the packet network. I mean, there's a huge slew of things happening. And our goal is to track that and educate everybody whether you're a practitioner, whether you are an executive, or whether you are somebody who's looking at this from an analyst perspective and trying to understand where the industry is going. So that, guys, is my brief introduction to the objective of this whole exercise. Now let's dive right in, to what we want to be discussing today. So let me again switch out of this screen. And go back to how we are organizing, the problem of organizing information that is available on the group. And so starting about a couple of weeks back, I began to put information into a mind map and make the mind map itself available as an embedded software file in my blog post, which is, by the way, a clickable file. You don't need mind map software to actually use it, and you can then click and actually jump to discussions organized by category. So let me share another screen which shows you how I've organized the mind map discussions for this week, and they are right here. So this, folks, is a mind mapping software that I use, but when I put it out on the web, it's really put out as a clickable file that can be opened in your browser. And as you can see, I've captured kind of the main categories of discussions that happened in the last week. There was a lot of discussions on the cloud. If you click on this, you can see the 4 or 5 key discussions, and you have links to them right away. You can jump by right-clicking and opening the link. In fact, and if you are seeing it on the web browser, if you simply click on the LinkedIn icon, you can see the location, and if you click on it, you'll jump to the discussion. So we've organized discussions by category. Let me quickly walk you through them. Obviously, I'm not going to go through all of this in this Hangout. What I'll do instead is I'll pick and choose a few of them which are the most interesting in my opinion, talk to you a little bit about the conclusions that came out of it, which is where the value is for this Hangout. And then if you've actually followed those discussions and you have questions, you can ask them. If you were unaware of those discussions, this is an opportunity for you to find out what is going on. And it's like a buffet. Not everyone is interested in everything. So what's going to happen is that my goal is that by becoming exposed to all of the various activities in the group, people who are interested in certain topics at least now know where those topics are being discussed, what the key issues are, and they can then go back and read those, and even then come back with new questions either on the group or at a subsequent Hangout, which I'm hoping is going to be a regular feature every week or couple of weeks, depending on what's important to talk about. So last week there were lots of discussions on the cloud, and I'll talk about these in some detail in a few minutes. The other area where we had a lot of discussion in the last couple of weeks has been in the area of traffic management and quality of service. So people asked about, how can you monitor performance? If I'm going to be monitoring the uptime of a service in a carrier Ethernet network, what are the best ways to do that? Should I use S-flow and NetFlow and the IP-based technologies? Should I use something defined by the MEF? Then there were two very interesting discussions that relate to why is the committed information rate and excess information rate actually an average? That's a very interesting question because it basically forces you to understand how meters and policers work and really at what time scales we are measuring these things. And then Eric Tim of TDS asked the question about whether there are any standards for committed burst size. So we'll come back to that. The other interesting things that came out were the impact of streaming media. The rate at which streaming media is growing, the rate at which Netflix is growing, and of course the new definition of the FCC, which now says that broadband speeds are 25 megabits per second and above, which is keeping in line with the volume of streaming media that people are consuming, and you need higher bandwidths to really be able to do that reliably. And then there was an excellent discussion about the virtual CPE, which has been something that's been discussed on and off in the group. In particular, I'd like to call out some presentations on distributed NFV that our colleagues at RAD did, which also talk about virtualizing the CPE by essentially putting a server blade, which is very cheap nowadays, into the CPE box and executing some interesting functions like security and encapsulation right at the CPE device. They call that the distributed CPE. So that's a discussion you'll find in other discussions of the group and has been covered in summaries of some of the previous weeks. And then there was discussion about how the submarine network is evolving, and I clubbed the 100G sort of evolutions with that, because submarine networks have moved to 100G and multi wavelengths with DWDM technology. And as you can imagine, no update can be complete without today a discussion of SDN and NFV. And we're really fortunate to have Tom Knoll and people like Scott who've been writing about these and educating us on the subject. So there's a bunch of discussions that talk from Tom Knoll and Scott that talk about the different aspects of SDN and NFV that I would encourage you to check out. And some of that will be covered in the write-up that we'll post subsequent to this Google Hangout. And then every week there's a lot of industry news that gets published on the group, and I kind of clubbed that here. This could include announcements from companies, products, conferences, some thought leadership, articles published in various forums, and they're all sort of clubbed in here. So this is how the information is organized, and as I said, this gives you a little bit of a better navigation tool for how to see what's going on in the group. So once again, let me just remind people that our questions are to be posted on the LinkedIn group on the discussion. So let me quickly bring that back on. And talk about just a moment here. So let me do a screen share. So just going back and reminding folks that if you have any questions, please either email them to me if you don't have access to the web page, but if you do, then please post it at the bottom of the discussion here. So I'm just going to do a quick refresh in case people have had some thoughts and there's some things that they might want to discuss. Okay, so we don't have any new comments so far, so I'll keep going. Let me just stop presenting and so we can have a conversation. Scott?
Yes. Hi, Vishal.
Okay, just wanted to check that that you're still available. So what I was going to do next, Scott, is cover a couple of the discussions that I wanted to talk about that were interesting on the group last week. Two in particular, some relate to data centers and the evolution of NFV, and a couple relate to traffic management and QoS, which I think is always an interesting subject to talk about. So guys, I have my notes here, which are summaries of some of the key discussions that happened. So, the first discussion that I want to talk about is a very interesting one from Patrick Lopez, who talked about NFV in 2020. And the two important things that I want to summarize from that discussion, which I think often get lost, Scott, in the hype that we have, is that NFV as it stands today doesn't really allow for an out-of-the-box commercial deployment. So there's a lot of things, missing pieces that any vendor or any service provider who's implementing NFV has to put together to make it happen. And Patrick, in his very, very concise post, has given a list of challenges in two categories. Now, one of them is just the operational challenge of training the workforce. And I think, Scott, you've mentioned that and observed that in some of your posts, that there has to be a complete mind shift at the operator for NFV and SDN adoption to really happen. And I wonder if you have any thoughts on what are some of the things that might need to change for operators to really make this NFV SDN a reality.
Great question, Vishal. I've actually been in the middle of a big research project on service orchestration. And so I've been interviewing 1 to 2 service providers every day, and I'm learning a lot about exactly what you're talking about, how they're migrating to this new model. The first observation I'll make is a lot of them believe that it's a fundamental change, and they're moving that way, and they're actually implementing technologies that will bring software-defined networking to their network. So it's actually happening. It's not just hype. The second element is that I've heard remarked from several people is that they feel like they have to build a software culture in their organization. And what does that mean? Well, if you look at the way, for example, cloud companies work, somebody like Amazon or a Google, they're very software-oriented organizations. And there's this culture in service providers that's been around for decades, which is, oh, I have to buy a box for that. I have a new service. Whose box do I buy? Amazon and Google don't think like that at all. They have huge pools of software talent, DevOps teams, open source developers who are constantly solving problems with software. And so I think that's the big shift here. Culturally, service providers are going to have to move to a software development culture, which is very different. And I've heard several, very prominent CTOs have remarked to me that this is the biggest challenge in their organization.
Absolutely, and you're quite right about that, and that actually segues to how this is different for the operators. In fact, going back to Patrick, he basically divided the NFV strategies that are currently operational into 3 groups. He said that roughly there's operators that are rolling out virtualized functions in software with just one vendor, and this is an approach, surprisingly, you'll see that there's also a geographical divide. So this is something that the Japanese and the Korean operators have been following. And then the other sort of approach is of operators like Telefonica and Deutsche Telekom, which are stimulating the industry by developing standards, participating in forums, doing POCs, and a lot of internal development, which is both time and resource intensive. So obviously that's being done by the big guys. And then there's the approach of maybe the North American operators, of which AT&T is an example, which are very specifically defining specific things that they want to virtualize. And they are defining how they're going to deploy that and manage that and maintain that. And having defined that model, they then work with a small ecosystem of vendors to implement that specific functionality. Now, the negatives of that are, of course, that you have proprietary integration and you have vendor inflexibility because you're working with only a limited number of vendors. The positives are, of course, that you get a tailored experience and you meet your specific needs as of right now, even when things have not really reached standardization. And then the last approach, of course, as we might imagine, is the wait-and-see approach, where operators are not, they're just placing bets. They're observing what the other guys are doing, maybe the big guys or the people who are at the forefront of this, the entities of the world and so forth. And they're trying to make sense of it and see how are they going to follow in the footsteps of those that are leading. So these are the 4 sort of approaches that Patrick outlined. And it was interesting for me that they also divided along geographies. I mean, different regions of the world have very different approaches, at least as of now, for NFV strategies. And I know you're interviewing a bunch of the operators, and some of the results are probably even just coming in as we talk. So I'm not sure if you're going to see that, but that's something that Patrick seems to have seen, in his analysis, and he's been talking to a lot of the HC participants, and that's how he's arrived at this conclusion.
Right. Yeah, exactly. There's a lot of dynamic changes going on right now.
And then the other interesting presentation post that I wanted to talk about, and I'm just going to do a screen share here so I can actually show people what we are talking about, and they can actually focus on something. So just a moment ago I was talking about Patrick's post, which is linked here, "The Future is Cloudy." And then I want to quickly focus on this very interesting Sienna post, which talks about data center. And what's interesting is that in 2013, in just the United States alone, according to the National Resource Defense Council, US data centers took 3% of global electricity production, and they consume 91 billion kilowatt hours. And by 2020, this is going to go up by 50% or more to about 139 billion kilowatt hours. So Scott, this brings me back to the green data center discussion you had a couple of months back, and the need not only at the enterprise service providers but also at the enterprises to really rethink data center power consumption strategy. And of course we know the likes of Facebook and Google, they're reinventing data center design completely. But the Sienna article outlined 4 or 5 techniques to do that, and I just want to call out a couple. And they started with something so fundamental you may not even think about it, which is, guys, take inventory of your power usage patterns. You know, what time of the day are you using patterns, and what time of the and what are the tariffs at that time, and kind of map that out to see if you can match power consumption to tariffs. The other thing they mentioned, and we all kind of know that, is to use data center management tools to analyze your assets and capacity and energy management and get a read on what your consumption really is. And once you've done that, then of course you can look at techniques to go green. For example, using free cooling, where you have outside air and water that is used in the data center, and you have smart temperature control in the data center. But all of that, of course, requires upfront thought. And then the other interesting thing I just want to call out is, which is important for us in the Carrier Ethernet group, is that they talked about the need to upgrade the metro network. And this is because the metro network plays a key role in data center interconnectivity. So if you can decrease the cost and simplify the designs of the metro network, you can increase the agility with which you can interconnect the data centers, and you can decrease power consumption by more efficient movement of data between the data centers. And what this really, the cornerstone of this, and this should be a great inspiration to the members of the Carrier Ethernet group, is that Carrier Ethernet technology is by far the most popular one for this interconnect in the metro WAN. And that's there's a lot of advancement happening there, and I refer you to the article to go look at some of the areas that they talk about, which can be very valuable as growth opportunities for members of the group, that are looking to professionally expand their areas of expertise. And the last point they mentioned was server inefficiencies. And the only thing I want to note there is that almost 30% of the servers, virtual or otherwise, that we have in a data center, large data center today, according to their statistics, actually may run as zombies. So it's a problem inside the data center of asset management and asset tracking, which we've had in service provider networks for years. We know that there are service providers whose NMS system may not track resources in the network that have been commissioned but are no longer being used, and there's a lot of wastage that way. Apparently similar things happen in the data center, where 30% of the servers can operate as zombies, and if you can't wrap those servers up and bring them back into operation, you're burning power like crazy. And fortunately for us, virtualization technologies are helping in that, because by virtualization you can have virtual servers and you consolidate multiple servers under one compute resource. And so it's a lot easier for you to track that compute resource and see if there are servers running on it which are not really doing anything active. So that's one interesting discussion that I wanted to draw attention to. And Scott, what I'd like to do next is segue from here right into your sort of discussion about the Cloud WAN services. And then later on, I'm going to come back to two interesting discussions on traffic management that I wanted to address in this Hangout. So Scott, I'll let you, I'm going to stop my screen share. I know you had some information to share, so I'm going to let you take over the presenter role and lead us through what you've been discovering in your research on the Cloud WAN, and really what is even the Cloud WAN.
Okay, great. Thank you. Thank you, Vishal. Do I need to do anything to take over presenter, or?
No, if you can just use the screen share icon that we were looking at yesterday and share your screen, what I'm going to do is I'm going to pin it. So when we talk, my video doesn't interfere with your presentation, and we should be good to go.
Okay, got it. So let me just talk about what I'm doing real quick first. So for those of you who don't know me, I'm an independent analyst. I have a website called the Reno Report, and I've been involved in networking and telecom for 20 years. And what I try to do is I pick a topic and I do a research project around a theme, and then I gather a lot of data, and often I do a survey. In this case, I didn't do a survey, but I conduct many interviews, often 20 or 30 interviews, and I try to build a picture of what's going on. So I'm working on, I have about 5 of these scheduled this year. I did, the first one I released last week is called The Future of Cloud WAN, and I'm working on one now on lifecycle service orchestration, so you might want to check those out. the first one is the one I just released is Cloud WAN. So let me show you a. I'm going to share this PDF. Can you see that, Vishal?
Not yet, Scott. Okay, I can see it now. You
Okay,
might
so
wanna, there might be a button there, Scott, which says share with everyone or something, and I was not always using that effectively, so you might just want to select that.
it just says screen share. That's all I get.
Okay, then I'm hoping that it should be also visible to the attendees, and I'm going to pin that now so that I don't keep.
Right, great. So this is the summary of my feature of Cloud WAN, and just to define what Cloud WAN is, some people call it SD-WAN, software defined WAN. So it's basically replacing the infrastructure you use to access a wide area connection with predominantly software rather than a collection of proprietary hardware. And this is let's call it a micro trend within the macro trend of software-defined networking. This is software-defined networking in the specific context of the cloud WAN. So, what did I look at? I looked at defining what is cloud WAN. People have different definitions of it. I looked at what were the drivers. Why would you want to move to this new cloud WAN world? We looked at some calculations for looking at the opportunity. How big is this market? And then we have some sample WAN architectures from some of the larger players. These are players that are moving the market. It's a mixture of incumbents and startups. And then I make some predictions, and on my appendix, which I usually have in every report that I do, a really broad summary of who's in this market and what they're doing. Now I'm sharing this report. Of course, it's for sale on my website, rainoreport.com. So I can only share pieces of it because I earn my living by selling reports. So I will go over. Why don't I just go over the executive summary first, and then we'll look at a couple of the architectures. So here's the executive summary and the key findings. One thing we found is that the total opportunity for a variety of cloud WAN services is going to be many billions of dollars. And why is that? Well, you look at what is out there now, like how do you connect to a WAN, and there's different types of WAN services and different types of technologies, including WAN optimization, multi-link aggregation, VPNs, IP VPNs, private lines, all these different technologies, but they're basically for building enterprise WAN connectivity. As this moves to the cloud, what's interesting is you're finding that some of these technologies are being combined in a new cloud WAN service. And think of it as a virtualized enterprise network, and in some cases a network as a service. The next bullet point, these are just some of the technologies I talked about that you find in the WAN. And in the old world, let's call it the hardware-centric world, what you usually got was a box with all these. So you needed an application delivery controller. You went out and shopped around for the enterprise, and you bought a bunch of F5 boxes. Or you needed a virtual private network, so you looked at the available technologies for VPNs, and you installed an infrastructure for that. Or you went out and you needed some WAN optimization, so you looked at the different technologies that were available. They tended to be boxes, so you would buy yet another box, and you would have a WAN optimization box. You can kind of see how you're getting the picture already of how this was a messy process. Buy a box for each service, and the cloud WAN is going to change that because picture it as just going to a web portal and saying I want a VPN, click, and it installs a software on your network. It's going to be as easy as that. So really what I talk about here in this report is Another big trend, again, this reflects a lot of bigger trends in telecom. This is the consumerization of technology, making it really easy for a business person to add a, add a function or add a feature to what they're doing. If you think about the cloud, that's what it does. If you look at Salesforce, it used to be you had to select a CRM system, talk to your IT department, negotiate with the big software license, figure out, buy a server, install the CRM server, install the software on the server in your closet or wherever it was going to be in the enterprise or the data center, manage that. Now, with these cloud services, the software services, you just go out and you just click a button and bam, you're there. You're using the software in a matter of minutes. This is what the telecom industry is trying to move towards. A more consumer-friendly way to download these features. Really, is what it is. Features in the cloud. So that's what's going on in a broad picture. I'll point out just another couple points, Vishal, is more than $360 million has gone into a bunch of cloud WAN startups. And what's their value proposition to the businesses? Well, it's really a return on investment. You can save on management, you can save on hardware costs. You talked about energy. There's energy savings and maintenance. And what's this mean for the incumbents? It means all these players with these specialized hardware devices are having to rethink about their business. How do they deploy this as a service in the cloud, and how do they virtualize the functionality? So you're going to see this trend continue. You're going to see the startups pushing the market, and you're going to see the incumbents adopting their solutions for the cloud. And this is also going to have a big impact on, of course, the edge router market, because that's where most of these services are predominantly controlled these days. And part of the premises cloud WAN is that you don't even need an edge router. So it's going to be interesting to see how this develops.
Actually, Scott, that is actually I think one of the biggest sort of findings in your report, because I know that one of the vendors that is covered is in fact Cisco. So some of the incumbents are obviously making a move into this to capitalize on the fast changing trends and move from software, hardware to software. But it really does represent a threat to the incumbents in a not an insignificant manner, right?
Yeah, of course. I mean, all these new technologies are constantly threatening the incumbents, right? But I think the big observation people have made about software-defined networking and cloud WAN and all these new cloud tools is that it's kind of the biggest shift in 20 years, and you've been doing it for the same way for so long. Like I said, the culture of the community has been, I need a feature or I need a service, I need to buy a box, right?
Absolutely.
And Cisco's whole business is built around that concept. If you go to a Cisco website, it's like, oh, what do you need? You need this feature, this is the box that you buy, or you need this switch to do that. So we're flipping it around now again to the software culture of where it's no longer about boxes.
So you said that there were a couple of things you might discuss specific to the architectures. Is that something you might want to do, or?
Yeah, I can show that real quick.
Yeah, I think that'll be interesting for the audience.
So let me scroll through this so you don't see, oh, look at this incredible report that you have to buy. I'll talk about like 3 different models. This is the Ariaka model. So Ariaka is a network as a service. So what does that mean? It means they've built out this global network of POPs, and they're offering WAN in the cloud by you accessing their POPs. So I like to think of it as Akamai. Everybody knows Akamai for content delivery. So this is Ariaka is like application delivery for enterprises. So you plug into Ariaka, and they have all this technology these boxes, first mile, middle mile, last mile, built into the network to deliver you all this functionality in the cloud. So you're plugging into their cloud and you're accessing, it's speeding up access to your SaaS applications, through various optimization technologies. So if you're going to Salesforce, the Ariaka network knows the fastest way to get you to Salesforce and get your SaaS application. It's got encryption, QoS, compression, IPsec security. So this is kind of a vision of the network as a service model for Cloud WAN. How do you embed all this functionality in the cloud so that all the user has to do is rent your network? So that's one model. This is
so all of the hardware. So the need for the enterprise to then purchase the hardware that you just spoke about, piecemeal and so forth, that simply disappears in this particular NAS model.
Yeah, I mean, I don't want to generalize. It kind of depends on a couple variables, like who your service provider is and how you're accessing the network. But the goal is to push all of this functionality into the cloud. So in some cases, you may not get all of this, without a box. You might need some kind of box or somewhere to download some of the software. But increasingly pushing these features into the cloud.
Okay, got it.
Okay, so let's look at another one. Let's look at this is Cisco's model, and what I observed was interesting was how much of it was connected to different devices. So you can see that Cisco's trying to move to WAN in the cloud with their so-called WAS service module and their WAS software, but you have to plug it into different places. So and WAS, doesn't offer all the functionality that we talked about. It offers pieces of it. So, Cisco's working to this model, but they obviously have a conflict in that if, they're going to sell you software that replaces some of their boxes, we know what that means for their box sales. So that is, I describe Cisco's conundrum as it's more of a sales conflict than a technology conflict. They have to figure out how to work this all out in the sales channel. So let's go to one more. Let's go to
by the way, they're moving, just as a side note, they're moving heavily into software because they just started a new data science group in Cisco. And a colleague of mine, his wife, who just did her PhD from UCLA, she joined them. And they're looking very actively at big data and analytics and the software side of things. So yeah, they're definitely working on it.
Yes. So the last one is VeloCloud, and VeloCloud is, I don't know if you can see my pointer. I'm pointing to this, but if you look on the left, the branch office, they're really focused on the branch office. Problem, which is, how do you connect to the enterprise and the data center, and how do you connect to SaaS in a more efficient way? And so they have a software-based solution for the enterprise. This is really about optimizing multi-links, and they actually deploy a lightweight device, but they manage the device, so you don't have to do anything. So I call this the cable model, right? Like when you call the cable TV company these days. They send you a lightweight box and you plug it in and it auto-configures itself, and generally you don't have to worry about configuring the cable box, right? So that's the model that we're going to. It's, again, this consumerization of the technology. Like why would you want to sit there configuring the router through CLIs for hours to set up your WAN, right? It's just people don't want to do that. And the VeloCloud approach is interesting because they are targeting specific markets, things like hotel, and energy, and where you might have hundreds or thousands of branch offices that have, a scalability problem when it comes to WAN. Like think about all these different branch offices using different technologies to deploy WAN. Well, think about if you have one solution in the cloud and you can point everybody in your enterprise to a portal where they just check some boxes and sign up for the cloud WAN, and it's there. And another thing that VeloCloud is working on is multi-link efficiencies. And what do I mean by that? Well, if you think about your average branch or even a home office, or what you have now is a variety of technologies to connect to the WAN, right? You have,
Sure.
often you will have a cable network and or DSL or fiber, and now you have 4G too, right? You can go to get a box or a transmitter from Verizon and have like a 4G hotspot in your home or your branch office too. So there's a variety of technologies. What VeloCloud does is allows you with software to tie those links, multi-link aggregation it's called, tie the different links together, and it has a smart system in the cloud that says, okay, there's more contention on this network, we're going to automatically switch you to this network. And so the big thing that VeloCloud is going after is making the internet more business class, so that you don't have to buy a private line or a private network. You can use the available internet connections, including 4G, and develop a enterprise class solution that way.
Okay, excellent, excellent. So
Is that helpful?
that's. Go ahead, Scott.
No, I was just saying. I hope that was. I hope you understand what I'm the picture I'm trying to paint here.
No, absolutely. I'm glad you covered 3 different architectures. I think that gives people a flavor of what they're going to discover when they actually read the whole report. So really appreciate that. I know you said you have another appointment, so I'm going to go back and discuss a couple of the things
I
on
can hang
traffic
out. I'm
management.
going to hang out for some more time. This is fun.
Okay, great. Thanks a
I'll
lot,
hop off
Scott. I
in
really
about 5.
appreciate
Thank
your
you.
time and joining
Thank you
us.
so much.
Yeah, we'll see you next time.
Excellent.
All right, guys. So I want to just quickly go back to something that I had promised in the outline of this broadcast, and talk to you about 2 things related to traffic management that I thought were very interesting and were discussed in our group. So let me do a screen share. Scott, you might have to stop the screen share so that I can then pick up from there.
I think I did.
Okay, give me 1 sec. For some reason, oh, I think I know. I got to click on my. I got to unpin you and click on my video feed, I guess. Let me see if I can get this done. Whoops. What happened here? Okay, guys, this is just the initial hang-ups of trying to figure out new technology. So you have to give me a minute to figure this out. Even though we have done a dry run, sometimes it takes a little while to get things back. So for some reason, I'm not being able to get myself on. Let's see. Okay, it tells me I'm presenting to everyone, and now I can share my screen. Okay, let me stop presenting for a moment. All right, so what I'm really trying to do here is get back to the mind map and walk you through a couple of the discussions that were on traffic management. Oh, there we are. Okay, guys. So I already told you the basic layout. What I really wanted to focus on were a couple of the very interesting discussions on QoS and carrier Ethernet that happened in the group last week. And in particular, I want to focus on this question that was raised by Aditya, who asked, and many people have this thought, why are the committed information rate and the excess information rate expressed as average rates? And in order to explain that, actually, let's just jump directly to the discussion on the group. And what I had explained on the group was that you really have to think about where these rates are coming from. So they're really coming from the policer, and the policer has. Okay, so I'm talking about this discussion that was raised by Aditya, which asked, why are the committed information rate and excess information rates treated as averages? And the reason is the following. So, in the network you have a policer which has a bucket, and the bucket is filled at a certain rate, which is called the committed information rate. and the bucket has a certain size, which is typically called the committed burst size or the bucket size B. So if you look at any interval of time t, the amount of data that can actually leave this policer is bounded by the bucket size B that you originally had, which was assumed to be filled, times the rate at which CIR at which you're filling the bucket times the interval t. So the total amount of data that leaves your policer in a time interval cap t is the bucket size B plus CIR times that interval t. So as you divide out by t, the total amount of data on average over an interval t that is going to leave the policer is basically CIR plus the bucket size B divided by t, which becomes smaller and smaller as the time interval grows larger. So that's the reason the CIR and EIR are all averages, and they're treated as averages in a nutshell. But there's a lot of interesting discussion in this thread, particularly from Larry, Ishkan, and several contributors that I think are worth reading to see what different views people took about how averages are computed. And related to that, there was another discussion from Eric Tim, which talked about, are there any standards for measuring committed burst size, specifically committed burst size on OBCs? And I'm just going to give you the punchline here. You can go and, of course, from this mind map, navigate to that discussion and read the thread. But the bottom line is that as far as the MEF is concerned, there are no real standards specified for how to set a committed burst size. If you, however, go look at the industry literature from the vendors, you see that they relate the committed burst size to the committed information rate, or CIR. Typically, the committed burst size is some multiple of the committed information rate. And we were wondering why that comes, because if you look at Larry's explanation on this thread, committed burst size doesn't really need to be related to CIR. In fact, Larry gave a few very nice explanations of how you can set committed burst size, and I'm just going to kind of go over those because I think those are very instructive to look at. And what Larry said is that if you have basically constant bitrate traffic, your committed burst size is going to be very small because you really don't have any variations in traffic. The other thing is that as your committed information rate or the average rate starts to reach the line rate, then you're also not going to need a large committed burst size because there's not a whole lot of room to burst. Because you're already close to line rate, all you can do is transmit at line rate. Then there are a couple of other cases that Larry talks about. Let me quickly talk about those from Eric's thread, and so that you have at least an idea of what the main bottom line conclusions were from that discussion. So give me a moment here. Let me bring up that. I'm not going to share that particular discussion because every one of you has access to it or can get access, but I am going to quickly go over the key conclusions so that you have a sense of what was talked about. So give me one quick minute. So what I'm doing is quickly navigating to that discussion so I can pull it up and give you the summary. Okay, here goes. Okay, the other way you compute committed burst size is that you look at the maximum frame size that you're going to transmit on the link, and you keep your committed burst size as some reasonable multiple, typically 10 times or 15 times that maximum frame rate. So if your frame rate is, the standard 1500 something bytes in Ethernet, your committed burst size is going to be 10 times of that, or about 15 kilobytes. If it's the jumbo frame 9600 bytes, and you're using this rule of thumb that you're going to have it 10 times the maximum frame size, then it's going to be about 9600 times 10 or 96 kilobytes. And that CBS is really not free because the larger you make your bucket size, the longer it takes to empty the bucket, and therefore the longer the delay in how you can
and how much in the data that you're going to transmit. So delay is going to get added. You're going to have queues further down the line to queue the data that that is released by a policer when you have a large committed burst size. And then there was some very interesting discussion on how TCP comes into this. That I'm not going to get into right this minute, because that requires a little bit of more sort of mental energy to look at it. But the bottom line is that Steve Haddock of the MEF is actually conducting some studies to determine how TCP performance gets affected when you set the CIR and the CBS and with policing and shaping. And it turns out that if you don't shape your TCP traffic and you simply police it, TCP performance can be very poor. So that's something that is being discovered by simulation that Steve is running right now. And I think the expectation is that the MEF is going to issue some kind of documentation or white paper after the study is completed, that's going to be available to the community at large to understand the effects of TCP and CIR. And then I also want to go back to two quick discussions that happened actually a month back, but also relate to this traffic management issue before we close out this hangout. And that was a question that was asked by our colleague at Sri Lanka Telecom, who wanted to know what are the actual performance parameters, packet loss, delay, jitter, and latency when you have a TDM over IP service. And it turned out that in this discussion, the conclusion was that the best way that you can get numbers for a TDM over IP service is essentially to look at the TDM equipment that you're trying to replace and benchmark the parameters based on that. So if the TDM equipment was giving you, 5 millisecond latency, 2 millisecond jitter, and I don't know, 2% packet loss, those are the benchmarks you're going to use when you transition to a TDM over IP service. And that's what the PSN network, the packet switch network that underlies your TDM over IP service should be meeting. Ideally, of course, the numbers you want to really aim for is a loss which is near zero, a latency that is essentially the latency of the TDM over IP equipment plus the propagation latency, and a jitter that is bounded by the buffer that your TDM over IP end equipment has, so that you can compensate for that using your jitter buffers. So those can be another way of getting a benchmark on what numbers you ought to pick for a TDM over IP service. But no specific numbers were presented in this discussion, because they vary depending on how fine a service you are planning to offer. And then the other discussion I want to quickly sort of go over is something that was asked by Sanjay of Aricent, who asked, who's trying to understand what flow-based technology should he use if he's trying to monitor an Ethernet service. Should it be the S-flow, NetFlow, etc., that come from the layer 3 world, or should it be the Ethernet OAM standards? And once again, this is a very interesting discussion that if you're in any way working in this area, you should probably look at. But the conclusion was the following, that if you want to actually measure the availability or the uptime of a carrier Ethernet service, probably the carrier Ethernet OAM standards are the most appropriate, and the IP flow monitoring standards are not. And the reason is that the IP flow monitoring standards give you kind of averages of what kind of rates are going through your network. They don't really tell you a whole lot about availability, which the OAM standards do, and you can do that through CCM-based uptime checks, which is the most effective way of measuring, the continuity check that you can do periodically to see if your service is up. In fact, even loss-based measurements are not really, an important point is they are not really measures that you can use to measure service uptime. You can use loss as a measure of service quality, but not uptime, because as long as your service is not 100% down, your service is up. And in the absence of 100% loss, you're only going to measure uptime. You're not going to measure service quality, because the service is assumed to be up. And then a good contribution to that thread was made by Marcus Freeman of NetRounds, who mentioned that the ITU Y.1563 standard actually does lay out some rules for how you can measure uptime, and they call their terminology is to call these severely errored frames. So basically Ethernet frames that are so badly errored because of transmission problems that you can't really correct them. So the service is deemed to be down when you have 10 or more severely errored frames, and the service is deemed to be up when you have 10 or more consecutive non-severely errored frames. and a frame loss ratio of 50% is deemed to be the threshold when you declare a frame to be severely errored. So this is another way of kind of looking at setting a benchmark or a threshold for how you can use these carrier Ethernet based measurements to decide the uptime of a carrier Ethernet service. So that is kind of sums up the key discussion that I wanted to highlight in this Hangout. I really want to thank you all for joining us, and those who are going to be viewing it later on. If you have any questions, please, as I said earlier, share it on the thread for the Hangout, or which is in the LinkedIn group, or share it on the specific threads for which you have a question, and we'll try to answer it depending on the complexity, either at the Hangout, the next one, or within the threads themselves. So, I really thank you all for joining the Hangout. And as I always say, until next time. All right. So as I always say, guys, until next time, may the bits in your bytes and the bytes in your packets be profitable. And I'll see you next time. Talk to you soon. Bye-bye.